There are two main branches of statistics, and we're going to be dealing with both branches in this course. The first branch is called Descriptive Statistics. So this is used to describe a collection of data. Basically, if you perform a study, nobody wants to see the raw data as it might be hard to read or there might be a lot of data to go through. Instead, we want to read summaries, or we want to be able to see something in an organized manner, maybe a graph or something. So that is called descriptive statistics, when you describe the data that you collected and you summarize it into something that's a little bit easier to read. In descriptive statistics, you're not trying to see if there's a cause and effect relationship. You're just summarizing the data that was collected. For example, a professor grades the tests of the 100 students in his stats class. One descriptive statistic we can calculate is the average mark of the class. The average mark would be a single number that can summarize what the mark the 100 students got was. Another way we can summarize the data is to maybe plot the data visually, and that would also summarize the data, but in a visual way it would show us where all the marks lie. So that is one branch. The second branch is inferential statistics. This is when you generalize the findings from sample data and you want to use it to draw conclusions about the population. Remember, you can't always access data on the population, so sometimes you have to choose a random sample and calculate data from the random sample. But once you calculate that data on the random sample, you can use it to draw a conclusion about the population. And from here, you might also attempt to do a cause and effect relationship. Does one thing cause another? Or does one thing affect the other? Now, these generalizations that we're going to make are just estimates, and they also have a measure of reliability attached to them. Those two measures are called the confidence level and the significance level. The confidence level is how often the estimate will be correct, and we typically want to be correct more often than not, so the confidence level is usually pretty high, 90 to 99%. The significance level is how often will the estimate be incorrect, and typically we want this number to be small, so it's going to be 1 to 10%. In later chapters, we're going to learn that the significance level is actually the letter alpha, and alpha will be used quite a bit when we're performing inferential statistics. So for now, we just need to remember when we're generalizing the findings, we need to attach a percentage to it. So one of the percentages is known as confidence level, the other is known as significance level, and they're actually closely related. If you're 90% confident, then the significance level is 10%. So these two numbers have to add up to 100%. Another example is if you're significant at 5%, your confidence level would be 95%. Again, the numbers have to add up to 100%. A quick example, if there are 1,000 students taking 2320 and we want to determine the class average, we can sample 30 students. Using the average score of that sample, so the 30 students, we can try and determine, that is infer, what the average score is for all 1,000 students. For example, if the average of these 30 students was 67%, you would probably make a safe bet to say that the average of all 1,000 students, or the class average, is probably close to 67% as well. So there, we are using sample data to draw a conclusion about the population.